Hello there, Algebra, and welcome back. We are starting lesson 7.6 today, which is factoring polynomials. So I know that 7.5 lesson was one that Mr. Prey had done. I want to do 3 videos, actually, 3 videos for this 7.6. So today we're just reminding ourselves that, hey, we know about factoring. We've seen it before. So our essential question is, how do I find the greatest common factor, or the GCF, of monomials? So let's just remind ourselves, what is a prime number? Prime numbers are a whole number greater than 1 that has exactly 2 positive factors. 2 positive factors, 1 and itself. So basically, it's only divisible by 1 and itself. Prime numbers. So when I tell you guys that I am in my prime, let's see if we could think about any of these prime numbers. 2 would be a prime. The next biggest number would be 3. 4 is divisible by 2, so that's not a prime. But 5 is. 6 is divisible by 2. 7 is our next prime. 8 is divisible by 2. 9 is divisible by 3. 10 is divisible by 2 and 5. So 11 would be next. Then we'd have 13, 17, 19. Then we have 23, 29. And we could keep going, right? We'd have 31, and then 37, then 41. There's lots and lots of primes. So these keep going. So factors are numbers that are multiplied to find a product. A number is divisible by its factors. That's just a different way of writing it. So we're going to talk about factors a little bit. So let's write out the prime factorization for 60. I really like to use what's called a factor tree. All right? It helps me. So with 60, I can think about how I know 2 and 30 go into 60. But 30 is not a prime. 2 is, 30 is not. Well, 30 is really 3 and 10. 3 is a prime, 10 is not. 10 is really 2 and 5. Hey, 2, 3, 5, all of those are prime numbers. So I know that 60 is really 2 times 3 times 2 times 5. Sometimes I write these in alphanumeric order. So I'll write the 2, the 2, the 3, the 5. It doesn't matter which way you do it. I like to do it this way, just because then I can see how many 2s I have easily, how many 3s. So that's the prime factorization for 60. All right, that's the prime factorization for 60. Another way we could have done it, instead of 2 and 30, maybe you saw that there was a 6 and a 10. That works, right? Because then 6 is really 2 and 3, 10 is really 2 and 5. So again, we get 2 times 3 times 2 times 5, which is really 2 times 2 times 3 times 5. So it doesn't matter which way you do your factor trees. We're looking at wherever we end, and that is our prime factorization. Again, I know you know this. We're just reminding ourselves, right? It's been a while since we've done anything like this. So let's try the next 3 for yourselves. Pause the video, try the next 3. Do a little factor tree, see what you get. All right, for 40, the way I did it was 4 and 10. 4 is really 2 and 2. 10 is really 2 and 5. So 40's prime factorization is 2 times 2 times 2 times 5. For 33, I got 3 and 11. And then for 49, 7 and 7. Ooh, 7 times 7. There we go. All right, let's turn to the next page. Ooh, there we go. So factors that shared by 2 or more whole numbers are called common factors. Common factors. So 6 and 8 have a common factor of 2, for example. The greatest of these common factors is called the greatest common factor, or abbreviated as GCF. So when we're looking for the greatest common factor, I do prime factorization trees of both numbers. So let's start with 24 and 60. For 24, I know that that is 4 times 6. 4 is not prime, it's really 2 times 2. 6 is not prime, it's really 2 times 3. So I have 2 times 2 times 2 times 3 for 24. For 60, that's really 6 and 10. 6 is really 2 and 3, and 10 is really 2 and 5. So 6 is really 2 times 2 times 3 times 5. So when I take a look at these and I have them written in order, I'm going to do this so that they're aligned vertically. 2 times 2 times 3 times 5. I'm going to take a different color here, and let's just go with green because it's nice and happy. And I want to see what common factors they have. What do they have in common? Well, they both have 2's, and they both have another 2, and they both have a 3. So their greatest common factor is going to be 2 times 2 times 3. Well, wait a second. 2 times 2 is 4. Times that by 3, and I get 12. So their greatest common factor is 12. So remember, these here are their common factors. Their greatest common factors when we basically multiply their common factors together. All right, I want you to try the next three. 18 and 27, 12 and 16, and then 15 and 25. See what you get. Pause the video, see what you get. All right, for 18 and 27, your greatest common factor should be 9. 3 times 3, 9. For 12 and 16, your greatest common factor should be 2 times 2, which is 4. And then for 15 and 25, your greatest common factor is just 5. That's all they have in common, because 15 is 5 times 3, 25 is 5 times 5. All right, let's take a look at our last page. So for our next one, we're finding the greatest common factor of monomials. This is where we start having some variables added in. So when we take a look at our first example here, we have 3x cubed and 6x squared. So I'm going to do a prime factorization for 3x cubed. I'm not going to do a factor tree in this case. I'm just going to write it out. So I know that this is really 3 times x cubed. But wait a second. X cubed is really x times x times x. So this would be 3 times x times x times x. You have to remember those exponent rules, right? You have to remember what the exponent is touching, and you also have to remember what those exponents mean. So that means I have 3 x's multiplied together. That's x cubed. So then we have 6x squared. 6 is not prime. 6 is really 2 times 3. And then I have how many x's? I should have x times x to get my x squared. So now when I look for the greatest common factor, they both have a 3 in common, they have an x in common, and they have another x in common. So that would be 3 times x, which is really 3x squared. That's their greatest common factor. All right, I want you to try the next two. So 18g squared and 27g cubed, as well as 10y cubed, 20y squared, negative 5y. Try those, pause the video, try those. So the greatest common factor for this one is 9g squared. The greatest common factor for our 3 terms down here would be 5y. Not negative, all right, positive. Positive 5y. This is the only guy that has negative. So positive 5y. Let's take a look at the last one. It's a little bit different. So I'm going to start with my 4x squared and writing out its prime factorization. That's really 2 times 2 to make 4 times, and I need 2 x's, x times x. And then I have 5y cubed. 5 is prime, and then how many y's do we need? 3 of them. So y times y times y. So now I want to look for what the greatest common factor is. Well, what do they even have in common? This is a tricky one. There is always at least one number in common. If they have no prime number or variable in common, they always have and write it in big letters. They always have ninja number 1 in common. So what's their greatest common factor in this case? Their greatest common factor is 1. All right, their greatest common factor is 1. Sorry, that was off the screen again. I apologize. All right, I have posted the skills practice. It's not on Big Ideas, all right? The skills practice is posted to Google Classroom. It is a Google form, not a quiz. It's just a Google form. You can take it as many times as you need to, like always. Unfortunately, Big Ideas did not have enough practice with this, and I want us to practice a little bit. Remind ourselves that we know how to do this. So go ahead and get started on your skills practice.